So what you should have found was that 4 squares works, 5, 6, and 7 do not. On the next page, 8 squares does not, 9 does. It's a 3 by 3 room. 10, 11, 12, 13, 14, 15, no. 16 does. It's a 4 by 4 room. 17, 18, 19, 20, all the way through 24 do not. But again, 25 does. It's a 5 by 5 room. And all of the above numbers who are able to form a square room are called perfect square numbers. So the 25 is a perfect square number, and the 16, and so on. And you should likely see a pattern here. What I need you to do is turn to the next page, and you're going to start the next page. You're going to pause this video to finish the actual page. What you should see on the next page is a table that you're supposed to fill in. And we'll do the first two together. So what you're supposed to do on the table is, first of all, list the perfect square numbers. And you can see on the side that I will have listed all the ones all the way down to 100. You're supposed to first of all draw the room, a sketch of the room, and you're supposed to sketch the length and the width. So inside you put the perfect square number because that represents the area of the room, and the length and width are the outside numbers. The next column, the dimensions of the room. This is a 1 by 1 room, a 2 by 2 room. And then you're supposed to find the perfect square root on your calculator, or if you know it, just write down the answer. And you get the square root of 1 is 1, the square root of 4 is 2. Now pause this video and fill in the rest of the page, and then turn the video back on and check your answers. All right. Once you've filled in the rest of the page, you should find out that you have this type of situation going, where you have a 9, the square root of 9 is 3, 16, the square root of 16 is 4, 25, which turns to 5, 36, all the way to 6, 49 to 7, 64 to 8, 81 to 9, and 100 to 10. What you should see that it's pretty easy to find the square roots on the way down because it just turns into the numbers from 1 to 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There's lots of patterns that occur here. For example, what do we do to all these numbers to find the number that's in the square root? Well, we multiply it by itself. 5 times 5 is 25. That's why in the diagram, the length and the width is 5 times 5 to get an area of 25. All right, turn the next page. And we have something to fill in here. A perfect square number is any whole number that can be represented as the area of a square. So any room that can be created using that number of squares, and if that room is square in itself, that number is a perfect square number. The side length of the squares is the square root. Now the square root symbol looks like that, and we write that as square root. When finding the prime factorization of perfect square numbers, there will always be two identical groups of numbers within the actual prime factorization list. If you find the product of each two groups, they will produce the same number. This product represents the side length of the square that the actual perfect square number forms. So let's do a couple of examples here. You're asked to determine the square root of 1764 using prime factorization. When we use prime factorization to do this question, we should find two identical groups. So 1764, again, you write that number down, and you're going to break it down into prime numbers. The smallest prime number is 2, which does go into 1764, and it's 2 times 882. 882 is 2 times 441. Now 441 looks like a big number, but again, 2 is not going to work because it's not even at the end. Let's try 3. 441 is divisible by 3, and it's 3 times 147. 147 is not going to be divisible by 2. It is by 3. 3 times 49. And 49 is 7 times 7. Now let's see if we can break this into 2 even groups. So 1764. I'm going to draw 2 lines like this with a dot in the middle. Remember, the dot means multiply. Well, I'm going to put this 2 here, so I've used it up, and then I'm going to put this 2 over here. This 3 is going to go here with a dot, and this 3 is going to go here. This 7 is going to go here, and this 7 is going to go here. So what I now have is that 1764, 2 times 3 is 6, times 7 is 42, times 42. If 1764 equals 42 times 42, what that really means is that if I was to make up a room with 1,764 tiny squares, I would be able to make a really big room with an area of 1764 that is 42 squares long and 42 squares wide. What that also tells me is that if the area is 1764 of this square and the side length is 42, that tells me that the square root of 1764 is 42. Next one. Determine the side length of this square using prime factorization. So this square has an area of 225. That tells me that the whole square is 225. And the reason we know it's a square, besides the fact that it tells us that it's a square, is that it has 4 tick marks. And those tick marks tell me that all 4 sides are the same length. So 225, not divisible by 2. Let's go with, we could go with 3, but right away you're probably going to jump to 5. So I'm going to go use that one to begin with. 5 times 45. 45 is 5 times 9. And 9 is 3 times 3. Let's try using our double rule. We're each going to have a 5. And we're each going to have a 3. That tells me that 225 is 15 times 15. Now what's the question asking me? Is it asking me for the square root of 225? Well, technically it's not, even though that's another way of asking the question. It's asking for the side length of the square. That tells me that I have a square of 225 in area, and the side length is 15. And that is the answer to that question.